Right, so this is tutorial number 1 for hydrostatic force in plane surface. If you can see from the picture, this is a vertical plate calculation. So the flow of oil from reservoir is controlled by a 5 meter wide L-shaped rectangular gate. When the question gives us the width, 5 meter. Okay, so this is the A that we will be using for the calculation. Hinge at point A, so it is hinge here at this point, point A. As shown in figure question 1 here, determine the minimum load W, so the W is here, such that the gate is just on the verge of opening when the oil depth is 15 meter. So the oil depth is 15 meter, the SG is 0.8, meaning the density of oil should be 800 kg per meter cube, because you just multiply SG by 1000. We have a stopper here to stop it from moving to the right. The total distance between W to the bottom should be 17. And because this is 17, the distance between the hinge to the surface of the fluid is 17 minus 15, and it is 2 meters. The distance between the hinge to W, or the weight, is 4 meter. Okay, so we do calculation on this based on the equation that is given to you just now. So I'll use different color here. All right, so to do this, first, because this is a vertical plate, it means your sine 90 degree is used for this particular study, because theta should be 90 degree due to the fact that this is a vertical plate calculation. So how are we going to do this? We go through one by one. Okay. Remember, whenever we have a question where the plate is, some part of the plate is submerged and some part of the plate is above the surface, remember the study of hydrostatic force only, we can only do the study on hydrostatic force on the surface where it is submerged inside the liquid. Other than that, we cannot do any hydrostatic force calculation there. So the one that we are using for the height will be 15 meter. Okay. So hydrostatic force in plane surface, in terms of vertical, so the equation, we will start with YC. Your YC should be equal to S plus, because this is a rectangular gate, we will use a centroid of B over 2. Okay, so the S should be the distance between the top of the plate to the surface of the liquid, but this distance is not available because the plate is extended out from the surface. So for this study or this question, the S is 0. Okay. How about B over 2? It's just plus. The B should be 15 meter divided by 2. So YC is equal to 7.5 meter. Okay. Now we find what is your YP. The YP is equal to YC plus IXXC over YCA. So we calculate IXXC. IXXC is AB cubed over 12. So equals to, the A is 5 meter, B is 15 meters, the power of 3 or cube divided by 12. So IXXC is A, so 5 times 15 of 3 divided by 12. Okay, the answer is 1,406.25 meter to the power of 4. Okay, The area is to A times B. So it is equal to 5 times 15. And this is equal to 75 meter. Okay. So we have this equation here. So what we can do is we will do the calculation for YP. So YP, this is from this equation here, is equal to YC, that is 7.5, plus IXXC, which is 1406.25, divided by YC, 7.5, multiplied by A, 75. Okay. So the answer for YP is equal to 10 meter. But for this study, the distance is from the surface to the center of gravity, YC, or the surface to the center of pressure, YP. So this number is higher than YC, so probably the calculation is correct. Okay, so we have YC and we have YP. So now we have to find out what is FR. FR is just rho G YC sine theta, which is for this question 90 degree A. So if we put in a number, because we already have 800, 9.81, 7.5, sine 90 is 1, the area is 75. So you get the FR to be 80 times 9.81 times 7.5 times 75 should equal to 441 450 Newton. Okay, so 441,450 Newton. All right, so that will be the FR. So are we done yet? No, because the question asks us what is the minimum load W required to hold the body from moving. Okay. So for this one, what will happen is we have FR 441,000. The FR is acting here through the center of pressure. Okay. So if we leave it this way, the body should be pushed to the right side. Okay. So to overcome, so right now what we are trying to find is what is the W that is here, because the W cannot be higher than the FR calculation that we have here. If not, if the W is higher, the plate will move to this side. Okay. So we want to know what is the minimum load that the gate requires. So that it's just on the verge of opening. Okay. So right now, the weight that we need to use is depending on the idea of moment. Okay. At the hinge. Okay. Or moment about the hinge. All right. So to find that, we just have to do summation of moment of the hinge is equal to 0. And we can see that the FR is moving to the right like this. So the moment should be positive moment. So we can just do positive FR multiply by the distance between FR here to the hinge, which is 2 meters here, plus YP. Why YP? Because YP is where you have your center of pressure, and Fr is acting on the center of pressure. Okay? And then, because W is moving clockwise, so this is a minus W multiplied by the distance here, 4 meter. Okay? Multiplied by 4 equals to 0. Okay? So to remind you back, moment is equal to force times distance. And the force must be perpendicular. Okay? Or 90 degree to the hinge. Alright? So we have this. So W is equal to, if W is being brought over there, Fr 2 plus Yp divided by 4. Okay? So Fr is 441,450 multiplied by 2 plus your Yp is 10 meter divided by 4. So W should be equal to 1,324,350 Newton. Okay. This is going to be the final answer for this question. All right.